Hello. So in this video, I'm going to show you how to make an efficient web scraper. This approach can also be used to fetch API requests in bulk. So first I'm going to show you an inefficient way to do these things. Then I'm going to show you the proper and efficient way. Okay, so first of all, we will create a virtual environment and is a good approach. Now that we have our virtual environment, all we can start coding. Okay, so for this example, I am going to fetch data from Binance. Just say that we need to perform a GET request on this endpoint for 100 times. So in an inefficient way, what we would do is something like this. So what this piece of code is doing is basically it fetches the data once and basically in a loop. So it sends a single request, then waits for the response, then it goes forward and does it again and again and again. So just reduce the number 10 so you don't have to wait for a long time. Okay, so as you can see, what it basically does is it sends a request, waits for it to return, and then it sends another request. So in this case, a lot of time is being wasted because we are actually waiting for the first request to respond. API can give us a rate limit of like 60 requests second. So that basically means we can do a lot more requests per second than we are doing right now. So what the efficient approach is based on is that we initiate a lot of requests at once while trying to stay under the rate limit, ensuring that we can get the data in the most efficient manner while trying to stay under the limit, the rate limit. But the approach or the module we are going to use is going to be async IO. We are going to asynchronously fetch multiple requests while we are waiting for other requests to respond. For this, we are going to need two modules. First one is AIO HTTP. We are going to use this for asynchronous HTTP requests, and the other one is the IO limiter. We are going to use this to try to stay under the rate limits. So we are going to use async limiter from AIO limiter. What this async limiter basically does is we're going to set a rate limit over here. For example, we want to set, let's say, 20 requests per 60 seconds. Now, what is going to happen that in our function, we are going to call this function. Now, what is this going to do is basically it is going to check how much, how many requests we can make while staying under the limit. So if we have already made more requests or we have already reached our limit, for example, we have already made 20 requests 60 seconds, then it is going to wait, it is going to make us wait until we have enough, we are eligible to send another request. So this is basically going to, this is a very simple way to enforce rate limits on our end. So what we have over here right now is two functions. This function basically performs the fetching. We are fetching the endpoint in this function. What this function basically does is it handles the bulk fetching of the endpoints. We are defining a session and we are using the same session for all the requests. The reason being that session takes time and we are saving time by using the same session for all the requests. So what this function is going to do now is basically it will run all the tasks in parallel. So it might overload the rate limit. Because if, for example, instead of 100 to 1,000, it will send all the 1,000 requests at the same time. What we need to do limiter.acquire. Now, whenever this function is called, is going to use this same variable for all the requests. So whenever it is called, it will check if we are within the rate limit. If we are not, then it will make us wait. If we are, then we won't have to wait and we would just simply perform the request. Let's set it to 100 so you don't have to long time. Let's add some tiny code so we can get the performance of both the approaches. Okay, so let's just test this first function and see how long it takes for 100 requests. As you can see, it took 33 seconds. Now, let's see performance of asynchronous code that I have here. Let's set the rate limit a bit lower. We are going to do 30 requests per second. As you can see, it just took 3 seconds, 2.5 seconds for 100 requests as compared to the 33 seconds we had to do when we had to perform the requests back to back. We can even go a step further and perform 1,000 requests. And we can perform 1,000 requests and you will see the difference in performance. As you can see, it took 32 seconds to form 1,000 GET requests. It took more time to fetch the requests back to back than to fetch 1,000 requests using this method. We can just change this URL from that of a JSON API to any page, and we can save the HTML to our hard drive and process it as we like.